Okay, so now what I've done is I've drawn up here the two situations we have with the liquefaction chamber before and after we've done the shaking. So what do you notice as a difference?
The soil has been compacted.
The soil has been compacted. That's exactly right. So we have two or three really things we need to take notice of. One is that the elevation of the soil has gone down. The reason for that is twofold. Well, the reason for that is that the soil has become better organized. So just like if you take a jumbled up box of cubes and shake it, the level is going to go down because they're going to fit together better, right? Does that make sense? The same thing happens here, where we see that these soil particles in its natural formation are unorganized. Well, after we get shaking, they move into a much more organized pattern. You can see that the void spaces go from being very present to being much more minimal. So as you have shaking, this elevation goes down and the void spaces decrease. In this case, there's nothing in the void spaces, right? In this case, we just have air. So since there's just air in here, we don't have a huge problem with these soil particles being moved because the air isn't going to move them as it's coming out. But what if we put something in there that's more viscous, such as water? What's going to happen then? So if we have this going down and now we have water in it, the water has to come out somehow. So the next thing we're going to look at is what happens in between these two situations of before and after. We're going to look at actually during an earthquake and what happens if we have water present in the kit.